Congruent. This means identical in all ways. So all the angles and all the sides on both these triangles must be the same. Now we can tell just by looking at this that they basically are the same. If I was to trace around the side of this, I could rotate it. I could just flip it round and it would look like this one over here. But we don't want to do this visually, we want to do it mathematically, and this is why we have these rules down here. It's a bit more concise than showing that all of it is the same. If I was looking at this up here, I could show that this angle here, I could work that out just by doing, there's 180 degrees in total, work out what this is, and I get the same result for this one over here. And I could do some trigonometry and work out these sides, so I could work out this side, I could work out this side, and it would be the same as these sides over here. So clearly they are congruent, just by exhaustively showing that they're absolutely identical in every way. Now these rules down here, this shows that if we have three pieces of information on the triangle, then they're congruent. But it has to be these three certain ones. For example, angle, angle, angle doesn't work because if I had this triangle here and I scaled it up, then it's got the same angles. They're not congruent. So it's only these combinations which work. The S stands for side, the A stands for angle, R stands for right angle, H stands for hypotenuse, so that's the longest side. Let's just see briefly on a couple of these why they work. So if I have SSS, this means that we have a triangle which has three sides which are the same on both of them. And we should be able to see that this works because if I was to try to move one of these corners or try to alter one of the sides, I can't do that without having an impact on the other sides at all. They're going to get impacted if I do that. So if I've got three sides the same on two triangles, then they must be congruent. These are identical, no matter how I rotate it. I can't really change these at all. But as soon as I move one of these, and we haven't got the sides the same, then they're not congruent anymore. Then if we look at the second one, SAS, now this means that two sides are the same. So this side here, and this side here, let's say that they have to stay the same, and any of these angles, let's pick this one here, that one has to stay the same. And again, I can't really move anything without altering it. If I move that down, then it's going to alter the sides, it's going to alter that angle. So again, it kind of fixes that triangle in that position if we have two sides and an angle of the same. I could go ahead and show this for the others as well, but you can take my word for it, they work in a similar manner. So we could tick off on here what we have. Let's just highlight it as we go. So we have this side of 7 centimeters. That's on both of them. So let's tick that we have a side, which is the same on all of those. Then if we highlight this angle here, we've got an angle of 32 degrees. That's 32 degrees on this one as well. So we can tick off that we have an angle, which is the same. Oh, missed a side off that one. We've got a side on the RHS. We've got a right angle triangle. So we could class that as this over here, so the R. But it's also an angle, so we can tick off on this one as well. So both of these have got a right angle. So you can see here that we've got three ticks on this one, angle, side, angle. And as discussed before, we could go ahead and show that these are all equal as well by doing trigonometry. It's a 1 mark question for one thing, and secondly, they want us to use the information we've got here. So we're not going to go ahead and prove these other ones. It's angle, side, angle.